Morning, afternoon, evening, forever you're watching. You're welcome back once again to the Making Masters, a channel so dedicated to demystifying mathematics, making complex problem look easy. What do we have today? Let's see what we have today. We have the set. What is a set in mathematics? A set is a collection of well-defined items. So when you're talking of sets, you're talking of things that you can quantify, that you can classify. For example, if a good example of a set is the mathematical set. Now, it is well defined in the sense that the mathematical set can be used for construction in mathematics, and the items that you have there all are used for construction. For example, you have the divider, the compass, the ruler. All those are elements of the set. But before we go to the elements of a set, sets are usually denoted by the curly brackets. We use the curly brackets to talk about the set. We don't use this kind of bracket. No, we use a curly bracket to denote a set. And the next thing you should know, they are usually written with capital letters. If I say A is a set of maybe let's say number of students in Nigeria or number of students in the USA in the secondary school, let me just put although ambiguous, but if A is a set of year 7 students in a certain school, this is how I will write it. A is equals to the set of students in year 7. So take note, sets are written with, denoted with curly brackets and also with capital letter. Now, let's talk about elements of sets. So we have already established the fact that sets is a collection of well-defined items, and they are usually written with capital letter and with curly brackets. Now, the elements of a set are the members of the set. Like the example I gave earlier with the mathematical instrument, the ruler, the pencil, the dividers that all form the mathematical set are members of the set. So element of a set can be written as the members of that particular set. For example, I say the set of students in SS1 in a certain school. If I begin to name them, those students, Tayo, Victor, Deborah, and so on and so forth, those are the members of that set. And when you talk about the element of a set, for example, if I say if A is equals to 1, 2, 3, 4, let's say natural counting numbers up to 4, 1 is a member of this set, 2 is a member of the set, 3 is a member, it belongs to that set. So for example, I can denote it. If I want to say 1 is a member, that means 1 belongs, you use the symbol to set A. We use the symbol to show that this belongs to this. If I say okay, 5 does not belong here. This is 1, 2, 3, 4. 5 is not a member of this set. So I can say 5 does not belong to set A. So this is what we use. Belongs to, does not belong to. Now the next thing we should know, the number of elements in a set. Number of elements in a set. Now look at the set. The number of elements, how many are they? 1, 2, 3, 4. You write it like this. Number of elements in set A is equals to 4. Number of elements in set A, that's also known as the cardinal numbers. So for example, I can give you a question like this. Take note, when you are finding the number of elements in a set, if I put 1, 2, 3, 4, I put another 4. It doesn't matter. Once there is a 4 or a number that is repeated, you count that number as a 1. So it doesn't matter the number of ones I have. If I put 1, 1, 2, 3, 4, 4, the number of elements in the set still remains 4. You only count the numbers once. Even if I have something like this, if I have maybe B is equals to, let's say maybe A A, B, and C. And I'm asked to find the cardinal number of this set. The cardinal number there, the number of elements there is 3. A is not counted twice. A is here, A is here. You count each of the elements once. Now let's move to the next concept. We need to know the subset. The subset is a set within another set. That's the subset. And for example, let's take if B is equals to, let's still use 4, 6, 7. Let's use 4, 6, 7. The subset, that's the set I can bring out from this set. If I bring out 4, is another set on its own. That's a subset. It's coming from the set here. If I bring out 6, that's a subset. If I bring out 7, that's another subset. So, number of subsets in a set. Look at, let's work it out. I can bring out 4 here. I can bring out 6. I can bring out 7. I can bring out 7. Now, let's combine. I can bring out 4 and 6 as a subset. I can bring out 4 and 7. 4 and 7. And lastly, I can bring out 6 and 7. Not lastly, sorry. Then, every set, take note, is a subset of itself. So I can bring out this 4, 6, 7 from this. So this is 4, 6, 7. And lastly, I can bring out the empty set. Empty set is denoted by this curly bracket, or you use phi. Take note, some students will make mistake and put this. No, this is not an empty set. It's either you use phi or you use the curly bracket with nothing inside of it. So let's count how many subsets we have here. 1, 2, 3, 4, 5, 6, 7, 8. Now there's a formula for it. Once you name the number of subsets is given by the formula 2 raised to the power of n. Now, if I have the number of elements there, I will count 1, 2, 3. That's 2 raised to the power of 3, which is 8. So this set is expected to have 8 subsets. 1, 2, 3, 4, 5, 6, 7, 8. All the number of, or all the subsets in a set is called the power set of the set. So the number of subsets a set has is known as its power set. Alright, this is a brief introduction to set. In our next class, we'll go further to look at algebraic set notation. Internalize this lesson. If you have enjoyed today's class, why not give us a like? Share the video. Tell your friends about the Making Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. And if you are here to subscribe, please kindly hit the subscribe button. Turn on the notification bell so you don't miss out on wonderful content on the channel. Most importantly, if there's any aspect of mathematics you are struggling with, put it in the comment section and I'll be there to attend to it. Till we meet again in the next class, keep practicing. Remember, mathematics is fun. Shalom.